My name is Becky Arnold, and I work for Lallemand Animal Nutrition in a fairly new role that we have created for Lallemand, which is the Custom Harvesting Business Development Manager. We've identified the importance of bridging that gap between the producer and the nutritionist and the harvester to make sure that we can get everybody on the team working towards a common goal of forage quality. So my presentation today is steps to achieving quality silage and the details that matter, and I've identified a few critical control points that lead us to silage quality. One, our goal is we're preserving nutrients in the process of ensiling. The second is harvest timing and moisture. That's probably one of the most important factors to achieving quality silage. The next is fermentation fundamentals that we're going to hit on a little bit, processing and chop length and monitoring those, and then pack density, which pack density is also one of the biggest criteria to achieving quality silage. So there's 4 different areas where we can lose nutrients and lose dry matter, and those are during fermentation, some seepage or leaching loss if we harvest too wet. We've got surface area spoilage, which can have a huge stance on whether on high losses or low losses, depending upon harvest practices and management. And then feed out management can also be another area where we can do really well or we can do very poorly. So factors that are going to help us achieve a quality fermentation include optimal moisture, which I alluded to in our harvest timing, plant sugars, which we need those in order to drive fermentation, aerobic environment and anaerobic environment. We want to take the oxygen away because spoilage organisms like oxygen, and our bacteria that drive that fermentation need to have an anaerobic environment without oxygen in order to do their job. And then the last factor is using a quality inoculant to help drive that process efficiently. So with small grain silage, there's a lot of issue around when is it ready to harvest and how long do we need to wilt it. So that's some of what we're going to hit on today. It's the golden question that we don't have a solid answer to because there's a lot of variables that can affect that. The goal, I have a very narrow window goal that I like to talk to with small grain silages, which is 38 to 40%. Good luck hitting that narrow of a window. But if we set a goal that's wetter than that, we might end up harvesting too wet. And if we set a goal drier than that, then we have a problem getting it packed because it's too dry and fluffy. So I keep it a very narrow window as I'm coaching people. With wilted silages and small grain silages, we have some challenges with soil contamination and higher ash because that ash and minerals are coming out of the ground, and where we're laying our forages on the ground to let them wilt, then we have to pick them up and we pick up soil with it, as well as just the process of cutting in the first place can create higher ash. So we want to do everything that we can to reduce soil contamination, whether it's during the cutting or during the processing to get it ready to chop or chopping it itself. And then as far as fermentation fundamentals go, I like to think of it in terms of we're harvesting all kinds of organisms. Some of them are good and some of them are bad. But we want to put the naughty bugs, the bad bugs, down for a little nap during the process of ensiling. And if we have an efficient fermentation, then we have less of those spoilage organisms that are going to wake up when we feed out silage. Whereas if we have an inefficient fermentation, we could be waking up a lot of organisms that are going to just continue to consume our nutrients and cause more spoilage and more dry matter losses. So achieving an efficient fermentation is pretty significant. And working for a company that produces inoculants my entire career, I am a believer in using inoculants to help overwhelm that process and drive that process to being successful so that we have more nutrients to feed our cattle rather than allowing our organisms, good or bad, to consume those nutrients. So that's where inoculant comes in. And then chop length and processing. If we're too long of chop length, then we're not going to pack very well, and then we're going to have sorting and some issues on the feeding end. And somebody needs to monitor these things throughout harvest because there's a lot of variables that happen, including equipment challenges that can happen on the harvesting side. We're monitoring our chop length or processing our kernels if we're talking corn or other forages. Those are things that need to be monitored in order to have good quality at the end. Packing density. I mentioned at the beginning of this that pack density is one of the most important things. That's where we can make or break it with our success. If we have poor density pack, we have a lot of oxygen and we have a lot of nutrient loss that takes place. And packing density is related to layer thickness. So the layers that we're spreading with the pack tractors, we want to be within 4 to 6 inch layers. If we get above 4 to 6, or if we get above 6 inch layers, we're losing density pack. We're not achieving our goal. So factors that influence density pack, the biggest one is going to be the rate of delivery for silage to the pile. If we can control our rate of delivery, then we can control that 4 to 6 inch layer thickness. If we have trucks coming to the pile way too fast, our pack tractors are going to get behind. So we've got rate of delivery, we've got the number of tractors that need to be there, which is related to an 800 rule. 800 rule is simple. Take your rate of delivery, your tons per hour, multiplied by 800, and that tells you how many tractors you need, the weight of tractors that you need to have on your pile. In some parts of the country, the 800 rule is applicable. In other parts of the country, mostly in the western US especially, we have a rate of delivery that there's no way that we can put that many tractors on the pile. So I'm going to talk a lot about that when I get into my presentation. The length and slope of the fill ramp can help us. If we have trucks that are coming in too fast, we want to elongate that fill ramp and give those tractors more room to spread out a thin layer. Packing layer thickness, we've talked about that. 4 to 6 inches is the magic number. Tire width and tire pressure can have an impact on it. Other factors, dry matter, moisture, particle size, tractor speed, but also the pack tractor operator has a big difference or has a big influence on how well we do. An experienced tractor operator is going to do much better than somebody that this is their first time. Okay, so that kind of wraps up the hot points of my talk that I'm covering today with steps to achieving quality silage. There's a lot that's involved, and a single factor by itself isn't going to make a difference, but actually knowing all of the details and marrying together as many of those factors as you can is what's going to help us achieve quality silage.